Hi there, welcome back to the channel. Welcome to something completely different. In this video, I'm going to do some work on this Amdek stereo 6-channel mixer, the MXK-600. It's a very, very simple mixer, and for me, this is going to be a bit of a palate cleanser. This little mixer belongs to a friend of mine, and he wants me to do a few mods on it, a few hacks. This thing's got some old capacitors in here, but more importantly, it's got an American main supply, so it's working off 110 volts AC. He wants me to convert this to European, so 240. So that's the primary focus of the work that I'll be doing on here. The reason I say this is a palette cleanser is that I've been working on this Nordmende Regulator 59 for ages. I did the first video, and then I think it was 10 or 12 back to basics videos on it. And then I did the chassis cleaning and the cabinet restoration. So quite frankly, I needed a break. And this is the short break that I'm taking. A little bit of a luxury. This is me having fun. And if you want to stick around, you're welcome. Now, I hate mixers. I really hate mixers. When you look at those mixing desks with about 300 knobs, to remove the boards, you've got to remove all the knobs, you've got to remove all the nuts. It just drives me nuts. Excuse the pun. But this particular one, when he showed me, I was pleasantly surprised. This is as minimalistic as you can get, and I really, really liked it. I like the idea of working on something simple for a change, something from I think it's the 80s, and with a task in mind, which is to convert this to a 220 volt mains power supply. Electrolytics have been in there for quite a while, and some cleaning and so on. So I thought, yeah, this will be fun. And I'm sure it's going to be, because this mixer is as simple as it gets. It's got 6 inputs. It's a stereo output, so you got left and right output, 3 levels for each input. So you decide how hot your signal is, and you can tone it down. You can then mix in how much of that particular input you want, and then you mix the master volume out. There's a power switch. It's very, very simple. I love it. It was put out as a Roland mixer. Don't ask me whether Roland produced this, whether Amdek was a branch of Roland. I'm not sure. I really don't know. I know there's a bit of a following on the web about this mixer, but I really don't know much about it. This is me with a bunch of components just chilling out. So join me. I might need your advice. Now, this thing is an Amdek stereo mixer. It was sold as a kit, and I believe it was produced or sold. I had no idea that they made these DIY kits in those days, but the simplicity of this is really what attracts him and me, in fact. This thing cost in those days £74, and they provide the schematic, which I'll look at closer in a second. You've got this whole thing describing the functions. You've got your 6 inputs. You've got your level switch, depending on what sort of input you're providing in there. These are jacks at the back. So this is single-ended. It's not XLR. And then you've got your pan pots, where there's going to the left channel, right channel for each one. And your sliders over here for the levels. Then you've got your master volume of it, simple power on switch, and really outputs, left and right outputs. That's it. Now, the problem with this is that it's an American system. So it's... Actually, that is strange, come to think of it. This thing has got an American transformer, so 110 or 115 volts main supply, and it's sold, well, it was sold in the UK, I'm sure, £74. But anyway, this article describes the whole thing, and of course, they've then got a whole lot of photos and everything else describing the various stages. So, yeah, it's pretty well documented. I guess it's pretty simple. I'm sure that the actual documentation that came with the kit had more information, but this is all I've got so far. And if we look at the schematic, as I said, it's pretty simple. The 6 channels are identical. Here's a power supply, which is the part that's probably going to be changed. I'll discuss that in a second. But if we look at this, all we've got is we've got a 220K input impedance over here. We've got a switch which determines what level you want your signals coming in. So basically this is a different resistor. This first op amp, this is a 4558S op amp. Those 8 pins in a row, so they're pretty old ICs and you probably can't get them anymore. This resistor here and that resistor will determine the gain. Then you've got another DC blocking cap over here. You get to the volume pot, which is the slider. And then of course is the fade, whether you fade left or right, which basically takes the 1/2 and sends it to ground, because these two go to the inputs of the left and right channels over here. So this one comes here, goes into there. That one comes down here, goes into there. All those feed into the same position, so they're summing, really. It sums all the signals coming into that op amp and that op amp. That one obviously produces the right output, and this one produces the left output. This master volume control over here is really a master gain for that particular stage. So yeah, what have we got there that we haven't seen before? Not much. Let's have a look at this. This is where I'm probably going to have a bit of a problem. Now, I don't have a better schematic, but it's not that difficult to figure it out. They've got a very, very small transformer, which I'll show you in a minute. It comes to a bridge rectifier. It's a single secondary transformer. So what they've had to do here, they want to produce, I think this is 8 volts, plus 8, minus 8 for the op amps. I can't really read that too well there. And what they've done is they've created a virtual ground over here. So if you imagine that these two AC points are coming in here to the bridge rectifier, that produces a positive, that produces a negative. And if you want to get this as a plus and minus supply, a dual supply, with these two resistors, you create a ground in the middle with 2 capacitors. So this is really a virtual ground. It's not the best way to create a ground. I would have used an op amp, but that's what they did in those days. And I think I'll have to change this because what I need to do is to replace this transformer from a 110 to, I think it's probably, what would it be? Probably about 12 or 14 volts. I need to make this a 220 or 240 to 14 volts. In fact, we're going to make this a little bit higher because I want to give this more headroom. As I said, it's very, very simple and there's not that much to the schematic. Okay, it's out of the chassis. Very easy to remove. A few screws, no big deal. That all comes out. It's got the internal chassis plate still stuck to it. So we're going to have to do something about that. If we look at the underside, we can see that everything's been hand soldered and it looks fairly neat. It's a pretty good job, but everything is fairly tight in here. Very tight, in fact. Surprisingly, they've used consistent color coding for each channel, which is nice to see. And here's our first problem. Everything is very tight in there. That little transformer, it's minute. And it is sort of stuck in there or bolted in there sideways because there isn't really much space there, which raises a problem. But we'll get to that in a second. Just another view. I took a lot of photographs to make sure that I put this back exactly as it was. And after removing all those little wires, I managed to get this out of the enclosure, out of the chassis. And I had a bit of a surprise because the capacitors you see there are the ones I intended to use to replace those power supply capacitors, and there's no way they fit on there, which is unfortunate, but I'll have to make a different plan. I have to use smaller capacitors, but here's the other problem. The transformer that the owner, my friend, got is too big for this. It's a really nice transformer, but it just won't fit in there. So I had to come up with an alternative, and I was fortunate because I had one. It's a 909, in fact it's 0909, so there's 2 secondaries. You can make them, you can wire them up in series, so you get a 909, which is perfect for this. It'll give us about 12, 13 volts, 14 volts maybe, and that'll be ideal. So I'm going to get cracking and show you how we get along. Okay, I've done this part so far, and all I've done here is change capacitors. As you can see, I've got these over here that have been replaced. These are the power supply ones. I was only able to put in the same values, 470, 100, 100, but they're very, very good quality Nishikons. And then here, these are the caps that do the coupling between stages. So I've used, again, Nishikons. By the way, these over here are the gold ones. I didn't have the 10 microfarads in these, what is it, KW, KA types. But this is what my friend bought, and I want to show you something. These are the originals. Very, very small. They're 10 microfarads, 16 volts. The 47 microfarads are the same size. And these are the ones we replaced them with. Now, you've got to be careful because they are significantly bigger. And when you put them over here, you've got to be sure that they fit because this goes straight onto that panel. That's screwed to the panel. So these things are just there. I mean, they just make it. You can just see that they will fit. If I put the angle right, if they were 1 millimeter taller, this wouldn't work. I'd have to bend them or something. So again, that's critical. But that's what we've got so far. I've cleaned the board with alcohol as well. And I had to do something here, which is what I said I was going to do. I found the ground point, what would be the floating ground, the virtual ground, and I've connected this to another little hole that I made on here and brought that through So that's now my ground. That's AC, AC. That's going to be, or those three are going to be the contacts from the new transformer. So I think what I'll do next is I'll put this in here, wire up the pots so that this thing is all wired up. Probably put the sockets in as well before I start playing with the power supply, because I'm going to have to figure out how I fit this transformer on there. I'm probably going to have to 3D print some sort of bracket. And this thing is going to have two signals to cut. This thing's got a single switch. It's only cutting the one supply line. Fortunately, this is a double pole. I believe this is double pole switch, so I can use the other pole to switch the other winding as well. Okay, I've got quite a bit done. I've wired everything up. I've put those in. Obviously, you just have to put those nuts in there and these screws. There are a lot of screws on here. What I did is I put a bit of tape, I don't think you can see that, on the back of this so that the capacitors, the metal part of the capacitors wouldn't touch at all. I don't think they would anyway, but I just didn't want to take a chance. And these have all been wired in. Now this is where photos come in handy. I took a lot of photos of all the wiring before I desoldered it, and it makes it a hell of a lot easier to, to get it done. Then I've prepared the switch as well. If you see this here, this is where the two AC lines will come. There's 0, I haven't wired in yet. And this switch switches both of them on and off. I've put another capacitor on this section. This switch was actually parallel, so I broke that parallel link. I've now got two separate switches, and I've got this 47 nanofarad, the same as that one, across that switch as well. This is going to go to the board where the AC went, and then the 0 volts is over there. But before I do that, I want to put this into the cabinet, make sure that it all fits, because I need to see just how much space I have for the transformer over there. All right, we're another step further. And what I've done is I've put it into the chassis. I've put all the knobs on. We never know, we may have to remove this. I've got to test it. I've got a couple of inputs coming in here from the signal generator. The channel 1 is this one, and it's at 1 kilohertz, 100 millivolts RMS. And this is channel 2, and it's at 2 kilohertz, 100 millivolts RMS. I'm going to put all the wipers down. I'm going to put this on least sensitive. This is a bit strange. I believe this is when the signal is high. This is the amplitude of the signal. So the stronger the signal, the lower down you got to go. It kind of makes sense, but I would have expected it to be the other way around. I've got the scope connected to the left and right outputs. Put that down as well. We'll keep an eye on the scope and see how we get along. Now, what I've done is I've connected two wires, soldered two wires to the positive and negative terminals of that big filter cap. So I'm not using the AC at the moment. I'm using DC, which means this thing will be doing a virtual ground. There's no transformer in here at the moment. And we'll see, this should work because the virtual ground should do its job. Just making sure everything is neat and out of the way. And yeah, let's check out the scope and see what happens when we power this on. Okay, I've got the supply at 12 volts, which means that the op amps will see 6 volts each. Plus 6 volts, minus 6 volts. It's low, I know, but I don't want to risk this thing. I've got this thing on current limit at 50 milliamps. Okay, I'm going to hit it. Let's see if we see anything on the scope. Nothing. Don't expect it because I've got these all the way down and these all the way down. I've got 20 milliamps being drawn. That's really low. Put that up high. See what happens. Oh, something is happening. Actually, let's put them both on max. Huh. Let me try something. Let me put this on the intermediate. Put them both on the intermediate level. The pan is straight in the middle. Oh, I'm getting a bit of clipping there. And it's clipping on the input. That's because I've got 12 volts. It's actually clipping on the input. Let me try and trigger this a bit better. Actually, I've just realized I've got both channels at 1 kilohertz, not channel 2 at 2 kilohertz as I thought. I'm going to increase the supply. That's 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's go to 22. Let's call it, or 24. Let's call it 11 volts, plus minus 11 volts. It's still drawing 20 milliamps. Oh, that's nice. Okay. Now let me try the pan. Let me put this all the way down. I've got this channel 1 being the only one coming in. This is on max. Left. Right. Okay. So channel 1's coming in. The signal's coming in and it's being split evenly both to the left and the right channel. Now if I pan it, brilliant. See that? It goes to the one side. If I go to the middle, there's a detente in there. There's a little indent in there. You can feel it right in the middle. If I go the other way, that works perfectly. Let me try channel 2. We should have the same situation. Why don't we? That's channel 1. Is my channel 2 not on? Channel 2 should be on as well. There may be something wrong with this. It's the bloody... Yeah, that's the problem. When you work with test equipment that's not perfect, that's what you get. Okay, channel 2 is now being used again, going one way and the other way. Perfect. Let me change channel 2's frequency to 2 kilohertz. That's channel 2 at 2 kilohertz and it's going evenly to the left and the right. Now if I bring this one up, we get the two summing. Perfect. Bloody perfect. Now I've got to be careful with this because, see this thing here, whoops, I've got it on the middle. Let me try something. Let me just work with one channel. And I want to see what the sensitivity is on this thing. Channel 1, 1 kilohertz, 100 millivolts RMS. I've got it on max and I've put this thing on the middle, on the bottom. So least sensitive. And I'm going to start increasing the amplitude. 700, there's 1 volt RMS. So it's still not clipping. And I'm going to keep going till I see it clip. There. That's where it's clipping. So the hottest signal is 2 volts. Well, just under 2 volts, 1.9 volts RMS, and it starts clipping. Now, if I go down, I'm going to go all the way down to 100 millivolts RMS. I'm going to put it on the intermediate, see where it starts clipping here. Whoa. That's really very sensitive. Starts clipping here at 190 or 170 millivolts RMS. Okay, let me bring this down to 10 millivolts RMS and assume we have a very small signal. Put this on the most sensitive and see where it starts clipping. Okay, that's 40 something. Let's see where it stops. 33 millivolts RMS, that's where that clips. And that's got to do with the headroom that we've got for the op amps. Now the op amps at the moment are working on plus 12, minus 12. I think with our transformer, that's about where we'll get because this is a 9 volt transformer. It's probably where we're going to be. The current draw is 20 milliamps and this is a small transformer, but it can handle it. This one can handle 110 milliamps per secondary. And this little guy, I mean, this thing is minute. I don't know how much current this could supply, but it didn't need to supply much, as we can see. But I'm a little nervous about working on that, on that one there, on the most sensitive. This would obviously be if you had microphones or something. Let's go back to 100 millivolts RMS. Okay, and our mixer is working perfectly. Obviously, I'm still going to check all the other channels, make sure they're all the same, but this is it. This is all there is to it. This is all there is to it. Let me try the frequency response on this thing. Put this a little bit higher, call it 100 millivolts RMS, and we'll see what happens. I'm looking at the output voltage, and I'm getting 6.56 volts peak to peak. I think I prefer that in RMS as well. Let me do that. Actually, let's do this properly. I've got the signal coming in at 1 kilohertz. I've got the amplitude set, so I'm getting 3.01 volts RMS on the output. I won't change any of the levels. I'm just going to change the frequency, and we'll see what we get. Let's go down to 100 hertz. That is 2.99 volts. That's flat. Let's try 50 hertz. 2.93 volts. Let's try 20 hertz. It's 20 hertz. That's 20 hertz. 2.96 volts. Bloody hell. 10 hertz. 2.86 volts. Hell, this is even, it'll go down even further, but let's try 6 hertz. 2.7. I mean, this thing just keeps going down. Okay. This thing is really flat. Let me go back to 1 kilohertz. There's our 3.02 volts. Now I'm going to try 5 kilohertz. 3 volts. 10 kilohertz. 2.96 volts. 15 kilohertz. 2.9 volts. 20 kilohertz. 2.82 volts. Let's go up crazy. Let's go 30 kilohertz. 2.59. 40 kilohertz. 2.26. 50 kilohertz. 1.92. And so on. Okay. This thing's pretty flat. We can see that if we use the 1 kilohertz as a base, I recorded on the screen what the dB deviation is. So this thing's pretty flat. That's great. And that's in the middle setting. I presume the others will be the same. This has really got to do with the capacitors that are used in the signal chain. We've used very big capacitors, 10 microfarad and 47 microfarads. So all the base can go through, and that's good. That's brilliant. Okay, time to get the transformer set up. All right, I've got the transformer in. This was a little bit tricky because, yeah, I had to make sure that this thing was perfectly tight in there so it wouldn't fray or come loose. This is a pretty thick shielded cable for mains. That's what my friend wanted. He actually made the plug and he connected the plug himself. And I finally got it in there, and I had to make sure that this thing was rigid, tight. And the way I did that was I connected everything in there, and then I hot glued that part which has the earth connected to the chassis over here. So I think it's safe. It can't move. I don't want it to move. I also don't want to make it completely irreversible. I thought of printing something, but I think this thing works better. Now, I've got 220 on here, or 240 volts on here, and I want to see what it is that we're getting out on the positive and negative. I've got the multimeter ground to ground, and I think the positive is here, 14.7 volts. And the negative, I think, is that one, minus 14.7 volts. That's bloody brilliant. Brilliant. Very symmetric. This works well. Now that means that we've got more headroom than we had in the first test. Remember, I put 20, what did I put on there? 24 volts, so plus 12 minus 12. Here we've got almost plus 15 minus 15, so it gives us a little bit more headroom. Right, so I'm just going to close this up now. It takes about 6 screws, no big deal, and probably give it one final test. And that is it. My palette has been cleansed and I'm ready for another tube radio. Okay, final testing. Let's see what we've done to this thing. We've got the same result. I'm just checking one channel here. I'll be testing all the others and leaving it to work for a while. But it's all working beautifully. Now what I want to do, let's see. Let's put this on max. And where was this clipping? Let's see where it clips now. I think it was 170, wasn't it? Now it's going up to 210 millivolts on the middle one. On the bottom one, what was it? 2.1 or 1.9 volts, I think it was. There's 2.1, 2.2, 2.3. Now it's clipping at 2.3 volts. So we've gained a bit more headroom, and I'm sure the bottom level will be exactly the same. Yep, I'm happy. I'm happy. My palette has been suitably cleansed. I'm now ready to tackle another tube radio. I've got a few boxes standing here. Some of them I haven't even opened. There's one particular one that I'm very keen to start. I won't tell you just yet. Keep the suspense going. And this one is done. My friend's going to wait a day or two while I test it, leave it running for a while, make sure this thing is not going to fail. I don't see why it should. So I hope you've enjoyed that. And if you have, click like, share, subscribe, and all. Oh, by the way, I've got a crazy brother in South Africa. He pointed out to me that I now stand absolutely zero chance of being the Madeiran with the greatest number of subscribers on my channel. And the reason is Cristiano Ronaldo just started a YouTube channel. He did it like 2.5 days ago. And by the last count, he had 38 million subscribers. So my chances are nil. I don't mind. But I just thought I'd point that out. That is it. I'll never play football like him, and I'll never have a channel with as many subscribers as he does. Yeah, but we've all got our own positives and negatives. So once again, thanks for watching. Bye for now. And most of all, stay safe.